Search in doubly linked list. Searching in a doubly linked list, this is the process of traversing through the list in order to find some particular value in the list. So if the value is present, you need to find that node, and if the value is not present, you have to return some indication that it is not present. So this is the process of searching in a doubly linked list. So let us say you have a doubly linked list like this, and you have a head pointer here which points to the first node. Each node will have a next pointer which points to the next node, and each node will have a previous pointer which points to the previous node. So this is how a doubly linked list works. In this lecture, we don't have much to discuss over what we had discussed in the lecture of singly linked list, because searching is pretty similar whether it be a singly linked list or a doubly linked list. So just for searching, you need not generally use a doubly linked list because it's not going to give you any particular advantage. So how do you search? You start from the head. So let us say you have a search pointer which you are maintaining. Initially, wherever the head is, you will point to the same node. This is your search pointer. This is your head. This is your search pointer. You are pointing to the same node. You will see whether the value matches or not. Let us say the value here is 10. Here it is 21. Here it is 35. And let us say you are searching for 35. Okay. So you are presently in this head pointer. You compared 10 with 35. Then you understood that, okay, the value in this node is not 35, which I'm searching for. So you will see the next pointer of this node and move to the next node. So now your search head is here. It's at 21. It is also not matching. You move to the next. You reach here. It is 35. Okay, you found that it is matching. Your search head is matching. So you return this pointer which points to the node containing 35. Again, as we discussed in the lecture for singly linked list, if you want to return an index, you have to keep a counter, keep it at 0. When you traverse through this, increment it to 1. Then when you reach here, you need to increment it to 2. And when you reach the node with 35 value, you would increment it to 3. That is how you understand counter is 3. That is, it is the third node. Generally in linked list, you will have to return the list which is having that value. In that case, it's better to keep a pointer and return that pointer so that when you return from this node can be directly accessed. So if a match is found, this is the scenario. What if you reach this last node and match is not found? Let us say you were searching for 71. So 71 is not in this list. So how do you understand the last node? Same as what you did in singly linked list. Last node will have the next pointer as null. So it doesn't have a next pointer. Generally, you will have a next pointer which will point to the next node. For the last node, next pointer will be null. So if it is null, it means that is the last node in that linked list. So if you reach the last node, that is the next pointer is null and the value is still not found, that means the value is not present in the list. So what do? You return some value like -1 or something, whatever represents that the search failed. Okay. So what is the time and space complexity? Time complexity, in worst case, you may have to travel through the entire list. So time complexity is order of n. Worst case, through the entire list. Space complexity, you're not using any extra space. So it is order of 1. So constant space, order of n time.